I'm Mika Page. My presentation is on machine learning with K nearest neighbor, for example. Okay, so AI is sort of a broad abstract concept. So TensorFlow, what Erica was talking about, neural nets, that's part of AI. So there's generalized AI, and that's sort of trying to get a machine to act like a human in all aspects, like it could do any task. And I'm pretty sure, as far as I could tell, like that hasn't been created yet. Like I don't have access to those kind of documents, but I'm pretty sure that it doesn't exist. And then there's applied, and applied is just sort of like day-to-day activities that are easy for us to do. So like recognizing a cat, we recognize it, very easy to do, very hard to code. And so in applied, there's rule-based, and that would be coding everything ahead of time and trying to anticipate every single situation and every single outcome, and obviously that's going to get pretty ridiculous. And then so there's machine learning, which you don't code in the rules, but you give it data and it sort of learns from the data. So there's deep learning, and that's a neural network, which I was going to talk about, but now you guys know all about neural networks, so you can just look at the image instead. And then there's what I'm going to talk about, which is not deep learning. So anyway, this is a definition of machine learning. That's the formal definition. Do you want me to pause while you guys read it? And it's basically saying that it'll produce better results. A machine is machine learning if it produces better results given experience, and experience is basically data. So there's 3 types of machine learning. There's supervised learning, that's what I'm going to talk about, and that's where it learns through data that's paired. So you give it data, and you also give it what the outcome is, and so it just sort of keeps track of that, and then you can train it. You can give it test data, and hopefully it gives you the right stuff. So you can do classification, like what type of stuff is this data? Are you looking at an old man? Are you looking at a baby? And then there's regression, and so that's more like if what you're looking for is a constant value, like age. So instead of a baby, is this person 12 years old? Is this person 72 years old? So I'm gonna do an example of this later, and so on to the others. Unsupervised learning, this is sort of like data mining, if you guys have heard of it. You just sort of, you give it a bunch of data, you don't tell it what you're looking for, you probably don't know what you're looking for, and you're just sort of looking for associations. So you want to come out with classes, but you're not predefining the classes. And then, so the next thing is reinforcement learning. And the funny thing is that everywhere I looked up, so I guess there's reinforcement learning in like in the biological world, but they still use the same words when they talked about machines. So machines get a reward and get a punishment. So I really don't know what that means. I think it's probably like, this is correct, this is not correct, and that's all the computer needs to feel like satisfied. So anyway, so the agent being the computer or the animal, it doesn't know the end goal. So all you're doing is you're giving it feedback. So positive feedback, negative feedback, and an action doesn't necessarily correlate with a certain type of reinforcement. So one action can get positive feedback, and then the next time you do that action might be negative feedback. And to explain that, I thought I would do it like the human way, which is to tell you by example as opposed to trying to over-define it. And so I'm going to give you one example, and you guys are going to know exactly what I'm talking about. So it has to do with dolphins. There was this, I guess it was sort of like anecdotal. I think it really happened. So they were training dolphins, and what they were trying to do is get the dolphins to always do a new trick. And they'd get fish, so I guess like snack time for the dolphins. So they would get a fish if they did a new trick that the trainer had never seen before. So the dolphins were doing all these tricks and getting fish, but then they stopped getting fish, and they couldn't figure it out. And then finally the dolphin did something just random and got a fish, and then all the other dolphins were like, you know, hell yeah, or can I say hell yes? I don't know. Just like, bleep that out. And then all of a sudden they learned it, because there's no way to communicate to them, do new things, except via fish. And so they figured out how to do that. Okay, so you guys understand reinforcement learning, right? High five. So that's like machine learning. Okay, so back to supervised learning. This is the algorithm I decided to work with. It's called K nearest neighbors. And guys, this, you can do this in JavaScript. So this is a Node library. I chose this less because of a preference in statistical algorithms and more because I found a tutorial online about how to do K&N. So thank you very much, Karen, for helping me find that. So this right here is just an example. It's a graph of flowers, and you can see there's no like spherical clusters, no like, between the red and the blue, obviously, there's like no, you can't really tell which flower is going to be which. Like even as humans, if we were looking at that, it'd be a little difficult to tell which was which. But the data points are associated with the type of flower that they are. And then K neighbors, K nearest neighbors, K is just how many neighbors, the closest neighbors that you have around a data point. The class that's the most, that appears the most is what the point is classified as. Lord, that came out weird. You guys know what I'm saying though, right? Okay, so if there's like five data points, 3 of them are the iris setosa, 2 are something else, it's gonna be classified as iris setosa. So anyway. So quickly regarding the math, Erica mentioned vectors too, and I didn't even know what vectors meant when it came to data points, when it applied to stuff like flowers until I read this, and so maybe this is helpful to you. But the data vector is sort of like every property, every characteristic is given a value on an axis. So it doesn't have to be 2-dimensional, it can be multi-dimensional. So petal length is x, sepal length is y, and then that point up there in 2D space is the vector. And so, and then the distance, so like z, like the z-axis, let's say there's some other floral characteristic we wanted to take into account, you know, it'd be out here somewhere. Am I gesturing too much at the screen? Like, is this cool? And then the vector would be like somewhere out there in space. And so as you feed it data points, you compare it to all the other data points. So it's going to be use Euclidean distance. And what's crazy, K&N, it does all this, like the training data. It's not like the computer is learning, the algorithm's learning over time. All the calculations are done at runtime, at test time. So like learning is just sort of like holding on to the stuff until you need to use it, which I thought was weird. It made AI like a little less magical to me. You know, I wanted to think of it learning like, I don't know, like Skynet. You could have just fed it 1 million data points, and then instead of using guns, and you would have been good. So, I don't know. I guess it was a little disappointing, but I guess I didn't use neural networks like you. That would have been rad. But like K&N, that's sort of like, you know, machine learning light. No offense to the people working in this. So anyway, so the Euclidean distance can work in any dimension. So you guys recognize this. It's basically the Pythagorean theorem, but I didn't know that a squared plus b squared through z squared equals whatever that new letter squared, the square root of that. No, you know the math. I said that wrong, but you know what I'm talking about. So anyway, so that's Euclidean distance. So it's just sort of, here's why Pythagorean theorem works, and then just sort of visualize it in dimensions. No big deal. Okay, so I'm going to code. So this is sort of, I did the tutorial, but sort of edited because they did the flower stuff, and I wasn't so interested. So I found this is sort of geared towards you guys. Oh, I gotta go really quickly, actually. So these are all animals, so cats and dogs. We're clearly super into coding about cats and dogs in this class. So I fed it a whole bunch of data about animals. So this is, you know, you require in K&N, you have a CSV to JSON, so you're just taking a bunch of data and making it into objects. Okay, so that's the code. So what I'm gonna do is you just run, you run the program. It's analyzing, it is learning and testing right now. So my percentage is a little lower than yours, Erica. For people who are just watching this now, I think she had like 3% error rate, and mine appears to be, is that 20% error rate? What's 50 out of 250? About 20%? Okay, whatever. It's smart, it's getting there. Oh, let me see here. So I made, I can't believe this, but I made, well, no, I edited another program, and I made a C program. So I'm going to make a dog. Oh, crap. Well, whatever. Let's feed it some other data, because live coding sucks. So So we can just like feed it in random data. I think like 0, 0, 0, 0, 0, unfortunately, is a cat. So it doesn't deal with outliers all that well. You know, it doesn't understand that that's impossible, but it does deal with big stuff pretty well. So node KNN. Like if it's a really clear outlier, like let's say, oh, and also I have no idea what the units of this random animal data was. I tried to figure out if it was in feet or whatever. So this is just an animal 1,000 units big. And so this is probably the dimensions of I have no idea. So, okay. So anyway, if you want to read more, here's the thing. So ML.js, that's the Node library that has a bunch of different, they even have a neural net kind of thing too. There's the machine learning with JavaScript tutorial. Machine learning on Wikipedia, man, that was pretty helpful. And there was a machine learning LearnDot, which is kind of sweet. It's in there so you guys can read that as well. Okay, nope, wrong swipe. So that's me, and I just thought, what tech talk can't benefit from an XKCD? So, okay, thank you guys very much.